Okay, this is lesson 2.1a, the derivative and the tangent line. Okay, we're going to start out with a little sketch here. That's good. Yeah, we'll just do a little first quadrant sketch. Let's do this little curve here. It's not very beautiful. Let's try again. Maybe I'll go through a point that's right here. And a point that's right here. A point that's right there. Maybe that'll help me out a little bit to get it better. Yes. Okay, that's beautiful enough. Okay, let's say that this point right here is A and this point right here is B. Okay, the coordinates of point A are going to be CF of C, because the corresponding X value right here for A is C. That means that its corresponding Y value right here would be F of C. And then the ordered pair for B is going to be whatever this X value is and whatever this corresponding Y value is. If we start right here where X is C and we go this distance, we call this distance the change in X. That little triangle, that is delta. And that means, that's your Greek letter delta, and it means change. So if we're sitting at this X value and we go this distance, then we have changed C by whatever the amount that delta X represents. So because we went to the right side of C, then we can call this X value C plus delta X. So that would be our X coordinate for B, which is C plus delta X. Therefore, your corresponding Y coordinate would be F of C plus delta X. Okay, so those are your ordered pairs for A and B. Now what we want to do here is we want to figure out what our derivative of this particular function is going to be. And the derivative is what would tell us the slope of the line that is tangent to any point on this curve that we want to use whatsoever. And that would help us to get the tangent line of that particular, where the tangent line is of that particular point is. So what I want to do is, let's say that I want to know what the slope of the line tangent to this curve at A is. Well, that would be this line right here. Give or take a little bit for human error. Okay, but that would be your, alright, so this is your tangent line right here, the red line, that's your tangent line. And that's what we want to try to figure out the slope of. What would be the slope of that line? Well, you know, to find the slope of this line through that point right there, you got to have 2 points. Well, a tangent line is tangent at just 1 point on a curve. So what we have to do here is we have to figure out, well, how can we get 2 points? Well, what we could do in order to do that is we could take the secant line that's from A to B, which is this line right here. There's your secant line, and we could keep moving B until, moving point B closer and closer to point A until we get it there. Like right now, here's our secant line, but we could take that point B and we could move it closer and closer, closer and closer. This is what I showed you the other day in lesson 1.1. We can keep moving it closer and closer and closer until it's really, really, really close to point A, and that would give us what that tangent line is right there. So we're going to see what would happen if we take point B and we keep moving it and moving it and moving it and moving it, and we got it really, 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 really close to point A right here, so we could get that. Well, if we keep moving point B closer and closer to point A, what's happening with this distance right here is this is getting smaller. You know, if we move it to right, if we move point B to here, then now C plus delta x is there, which made delta x shorter. If we move it here, C plus delta x is sitting right here, which made that even shorter. So this distance keeps getting closer and closer and closer. So what is it getting closer to? Well, it's getting closer to nothing. It's getting closer to 0. So delta x actually starts approaching where delta x is going to be pretty much 0, and that is the only way that we could get that tangent line at that point right there. So what we're going to do is we're going to take these 2 ordered pairs right here, and we're going to figure out, well, what's the slope? Well, we know our slope formula that we learned way back in, what, 6th or 7th grade, is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Well, that's the same thing as you're changing your y. The difference between 2 y values means how is y changing over the change in your x. How are the x's changing? So there's that delta x again. Okay, keep that in mind as to where it is. All right, so we're going to fill these in. Well, my second y coordinate right here is f of c plus delta x. And then my y sub 1 right here is f of c. And then x sub 2 is c plus delta x minus x sub 1, which is c. So right here, what happens after we fill in this formula is that these c's cancel, and our slope ends up being f of c plus delta x minus f of c all over delta x. Okay, well, c is any x value at all. So for that reason, what I can do is I can plug in the place of c, I can say, okay, well, my slope right here, this is actually the, my slope is going to be f of x plus delta x minus f of c for this line, but what I really want is to get the tangent line, I want delta x to approach 0. So for that reason, what we do is, instead of just saying that it's this, we say that we are going to take the limit of that. Oh, everybody loves limits. I love limits. We're going to take the limit of that and say that the slope would be the limit as x approaches 0 of all of this, and that would give us the slope of our tangent line. Okay, so this is the formula right here that you're going to have to remember because this is the formula that gives you the slope. It's called the derivative. Okay, this is the limit process for a derivative. And your derivative will give you the slope at any point on that curve. Okay, so it gives it at any point on the curve whatsoever. Alright, so the main thing that I want you to remember here is when I say derivative, you say slope. And that's my little cheer that we're going to be doing quite often, okay? When I say derivative, you say slope. Derivative, slope. Derivative, slope. You can remember that, right? Okay? Alright, so this ends part 1 of this lesson. Okay, part 2 is on its way.